So I'm recording now, just so you know.
Yeah.
All right. So when we're doing Lewis dot structures, we have to pay attention to the valence electrons. What were the valence electrons?
The ones in the outermost shell.
The ones in the outermost shell. Can you see what's on my screen?
Yeah,
Make
it
sure
says
it's okay.
valence E, right?
Right. I just want to make sure. All right. So that means we need to figure out the valence electrons in each of the atoms. So let's look for phosphorus on the periodic table.
Oh, great.
Huh?
I said, give me a second.
Look on the screen.
Oh, okay.
You good now?
Yeah.
Okay, so we're going to focus on the representative elements, which means the ones that are in the tall group. Remember doing this?
Yes.
All right. All right. So those are the valence electrons. Now, once we get to the transition metals, those seem to be a little bit crazier because we're dealing with the D block, and it fills the D block before the next S block. So it confuses people as to what kind of charge, what valence electrons are actually there. So we're going to primarily focus on the representative elements. All right, so
Okay.
how many valence electrons are in phosphorus?
5,
5. All right, now find fluorine.
7,
7. But we have 5 of them because it's PF5. So
35,
what's 5 times 7?
35.
Very good. You'd be
Wait.
surprised how many people get that wrong.
So we're recording. So can they hear me right now?
Yes.
Oh, I would say some bad stuff, but you're a teacher, so never mind.
Okay. All right. So what's the total? If we add these two together, what would they be?
40.
40. So our total here is 40 electrons. All right, so now we have to figure out what's the least electronegative element. So what's the trend for electronegativity?
What's the what?
The trend for electronegativity.
Um, it increases from left to right.
That's right. It increases as we get closer to fluorine, right? Up and to the
Yeah.
right. Okay, so what's the least electronegative? What's the furthest away from fluorine?
Phosphor. Oh,
That's right, phosphorus.
okay.
Least two. All right, so phosphorus is the least. So that means that's going to be the one that's in the middle. All right. So
Mhm.
phosphorus is in the middle on the right hand side. We also have 5 fluorines here. So we're going to put the fluorines around the phosphorus.
Caitlin, you're late.
What? Huh?
Yes.
Okay, you realize you're yelling at somebody on camera. Just throw that out there. Okay. All right. So the 5 fluorines around the phosphorus. Okay. All right.
Hmm.
We need to connect these to the phosphorus. So we're going to connect them inside, as such. You follow me so far?
Yes.
Now, how many electrons are in each one of these lines?
Um, 1. Or is
Two.
it 2? It's 2.
It's 2. So a line is equal to 2 electrons. All right. So
Uh-huh.
that means how many electrons do we have here total so far?
10.
10. So out of these 40 that we started with, we're left over with 30. Okay. When
Hmm.
we fill in the rest of these electrons, we're going to start from the outside and work our way in. I'm going to redo this so that way it makes it a little bit neater. All right. So we're going to work our way outside in. So we have 1, 2. I'm on the upper right hand corner. 3, 4. My dots are not working out real well. I'm going to make them.
No, they're not. I got confused.
Okay, hold on. Let's try this again. We're going to make this really dark, hopefully. Let me see if this one helps. Is that a little better?
Yeah.
Okay. Okay, so there's 6 electrons there. We're going to do the same thing with the next one.
Okay.
There's 6 electrons there, so that means that's 12. 2, 4, 5, 6, 7, 8. 2, 4, 6. I don't know why. So 6, 12, 18. 2, 4, 6. That's 24. 2, 4, 6. That would be 30. So there's our 30 electrons. Hey, Caitlin's here.
No, she just left, Dr. Chomri.
Why did she leave?
I don't know. Just keep going.
Okay. So, can you see my screen again?
Yes.
All right. So, as you're looking at the screen, you'll notice that we needed 40 electrons from the initial part here. And once we got our bonds in, we went back and we started doing lone pairs. Okay. Most things don't have lone pairs, or most things don't have single electrons. They'll be paired up. If they have a single electron, that's called a radical. Okay. And they are very unstable and they'll react very quickly to get rid of that radical. Okay, so I am on pH 3 now. This is the next one down. You with me?
Yes.
All right, so we need to go through it. We need to figure out how many valence electrons are in each. I'll pause this again. All right, so we're going to resume again. We need to figure out the valence electrons for phosphorus and hydrogen. Phosphorus we know from the previous one.
It's 5.
Right. I'm gonna pause. All right. So as you said, there are 5 electrons with phosphorus.
Yeah.
That's coming from the previous question.
Mm-hmm.
We gotta look at hydrogen.
1.
There's only 1 there. So just in case people don't know, those are the S&P block ones. Okay. So there's only 1 here. So what's 3 times 1?
3.
You'd be surprised how many people get that wrong. What's 5 plus 3?
8. Oh.
Enthusiasm. All right. So we have 8 electrons we're dealing with now.
Mm-hmm.
This is a tricky question. Because hydrogen looks like it should be the least electronegative, right?
Yeah.
But hydrogen will never be in the middle.
Why not?
So if hydrogen's never in the middle, what's going to be in the middle?
Phosphorus.
Phosphorus. So I have 3 hydrogens I want to put around it. The cheat sheet for doing this is the one you have the least of will be the one in the middle. Okay? Since I only have 1 phosphorus, but I have 3 hydrogens, hydrogen is going to be on the outside, phosphorus is going to be in the middle. Now, how many electrons are in each one of those lines?
2.
2. So we have 6 electrons used up from the bonds.
Isn't it? Oh, yeah. Okay.
Okay, so 6 electrons are being used from the bonds. Hydrogen not only will never be in the middle, it will never have more than 2 electrons. He already has 2 electrons from the bond itself. So can hydrogen have any more?
2 more?
It can't have any more. Because
bond
here, that's all hydrogen gets. All right? That's because he's in 1s2. He's 1s1, so his full octet is actually 1s2. So that means 2 is its max. So once it gets its bond, it's done. So if hydrogen can't get those other 2 electrons, where is it going to go?
On top of the P.
On top of the phosphorus. That's right. There you go. How do we feel about that?
Yeah, I remember that.
Awesome. Okay. How many more of these do we want to do? Or are you feeling pretty good?
I feel pretty good.
Okay. I'm going to
do one more for
What?
the people who. I said we could do one more for the people who decided they didn't want to show.
We don't want to call out anybody's name, so we won't mention the other 24
I'll mention
people
everybody in the class. Kaylin, she's slacking. Sarita, I just texted you. Who is else? Emily. Um,
Okay, that's enough now. All right, so how many valence electrons are in carbon?
Carbon. 4.
4, that's right. There must be something on my screen there. All right, there's 4 valence electron there. How about chlorine?
7.
7. So what's 4 times 7?
28.
All right, so what's 4 plus 28?
32.
So that means there's 32 electrons total. Now, which is the least electronegative, or which do you have the fewest of?
Carbon.
So carbon will be in the middle. Where is the chlorine's going to go?
Around it.
Around it.
I have a question. How are we supposed to do this on Google Docs, though?
Okay, so
It's all in there.
if you can't print it off, just put it on a separate sheet of paper, and like a loose leaf piece of paper or whatever, and just take a picture of it and send it to me.
Okay.
Okay? You can do it through Remind. It's really easy to text pictures to me. All right, so I have on my
Text the
bonus.
picture, Dr. Tom. You can't text the picture.
You can text it through Remind.
No, you cannot text a picture. You can send one.
Oh my God.
Okay, continue.
Seriously, this is what you're giving me crap about? Moving on. How many electrons do I have accounted for with this that are written there right there with bonds?
8.
So I have 8 accounted for. So how many do I have left?
24.
24. All right, so remember, we're going to work on the outside in unless it's hydrogen. Is there hydrogen here?
No.
No, so we're going to just put them around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, so we have all 24 accounted for now.
Ta-da.
Ta-da!
Okay.
Let me see if I can find one that is a expanded octet. This is my little thing about resonance. I'm sure you guys don't know what resonance is.
No.
Because I don't think I discussed it last year because I ran out of time. I was trying to
Do you remember double bonds, though? Do we have to use those for any of these?
You will for the resonance part. And I'm going to skip ahead. The carbonate resonance, I don't think it's on your worksheet. You're going to have to get out a separate sheet of paper right now to do these.
I will?
Yes.
Oh, okay.